In this video, I will define the concept of a limit and how to find the limit of a function graphically. What is limit? A limit is just a statement that tells us as to what value a function height approaches as input gets close to a specific x value along the x-axis both from the left or right. Informal definition of limit. So let's say here we have a function f of x. And here is a specific value for x, c. And as you can see from the graph, if I approach c from the right side, so let's say at this position the function value, this is the height of the function. At this point, this is the height. So when you get close to this one, the height of function is equals to l. Similarly, at this position, if I approach c from the left, and at this position is the height. When I keep going and when I close to c, this is the height of the function, which is again what L. So in this case, or in this situation, the function value stays L, whether I approach c from the right or I approach c from the left. So in this case, I will say this function has a limit of L as x approaches c, and we write mathematically limit x L c f of x equals to L. There are some important points. So if we know that function value at c is L, we cannot conclude anything about the limit of f of x as x approaches c. You know, the limit could be different from the function value. That's what we're saying. And if we know the limit of f of x as x approaches c is L, then we cannot say, oh, the function value at c is also f of c, or f c is L. Okay, not all limits exist. So there are three situations where the limits will fail to exist. Number one, f of x approaches a different number or value from the right side of the c, and then it approaches from the left side of c. So in other words, what we are saying is the limit exists only if f of x approaches the same value, whether you approach c from the left or from the right. So second situation is that if f of x approaches infinity, and when it becomes increases without bound, or it decreases without bound, it becomes minus infinity as x approaches c. In this situation, limit does not exist. Second, a function oscillates in swings between two x values as x approaches c, and in this situation, the limit again does not exist. So you have to remember these are three situations where the limit does not exist. So let's see. There is an example. Example 1. So here we have function f of x equal to absolute value of x over x. Now, so we want to know what is the limit as x approaches 0. So let's see from the graph, if I approach 0 from the right side, the function value approaches to what? 1. And if I approach 0 from the left side, the function value approaches to what? Negative 1. So we have a different function values when we approach 0 from the right, and then it approaches from the left. So in this case, we'll say limit. This limit does not exist. Example 2. Okay. So again, here the c is 1. You know, we want to know if the limit of 1 over x minus 1 squared as x approaches 1 exists. So let's see, if we approach from the right side, and as we approach from the right side, the function value to us keep increasing and becomes infinity. Similarly, if we approach 1, which is c value, from the left side, the function value keep increasing, infinity. So in this case, we'll say limit does not exist, because if we approach 1 either from left or right, the function value approaches what? Infinity. So example 3. So here we want to know what is the limit of sine 1 over x as x approaches 0. So looking at the graph, we can see, okay, if we, here's the 0. So let's we approach 0 from the right side. So let's see if we are here, that's the height of the function 1. And if we are here, the height is what, negative. And then if it's here, the height is 1. And now if it's here, the height is negative. So it looks like the function value swings between 1 and minus 1 as we move from right towards 0. Similarly, this function value swings from 1 between 1 and negative 1 as we approach 0 from the left side. So limit does not exist. Example 4. So let's find the limit of a function graphically. So here we want to know what is the limit of the f of x as x approaches 3. So let's see, here is a 3. Look at this. So let's see if I move along the x-axis towards 3 from the right side. So you can see if we are here, this is the height of the function. So if you keep going, the height is keep what? Going decreasing, and when you close to 3, the height is equal to what? 4. So that we can say the right limit is 4. Similarly, let's check. If we move towards 1 at this number 3 from the left side, so you can see at this position the height is this much, and the height is keep going up. And when you're close to this one, that's the height, which is 4. So we'll say left limit is 4 and the right limit is also 4. So limit exists and the answer is 4. So that's example 5. Let's find the limit graphically of f of x as x approaches 2. Okay, so let's look at this one. If locate the 2 is here. So if I move along x-axis towards 2 from the right, and you can see at this position this is the height, when it's close to, and this is the height, which is equal to 5. So you can say the right limit is 5. Similarly, if I move towards 2 from the left side, so at this position this is the height. If I close to 2, the height is 3. So we say left limit is 3. So now the right limit is 5, the left limit is 2. Two limits are different, so we say limit does not exist. So example 6, we're going to find the function value using the graph. So we're going to find f of 3. So we don't have to go from left and right, just locate the 3. 3 is here, and then we draw a vertical line, and it says it's open circle. So it looks like when x is 3, this open circle, so we cannot say answer is 4. If we keep going up, there is a solid circle, and here the function value is what? 5. So you will say f of 3 is 5.